Okay, so now we move on to section 4, true or false. Problem 1. If n is relatively large and p is relatively small, then Poisson distribution with parameter lambda equal to np is a good approximation of the binomial distribution with the parameters n and p. This is correct because that's exactly the reason why we use Poisson distribution to approximate the binomial distribution. And also remember that the Poisson distribution, if you plot it, it looks something like that. So it's very dense on this side and very loose on this side. And yeah, that's why Poisson distribution, if a binomial distribution looks like that, Poisson distribution is a very good approximation. And for second problem, the hypergeometric distribution describes the probability of k success in n draws with replacement from a population of size n that contains exactly m successful object. This is false. It looks very correct, but hypergeometric distribution is defined to be without replacement. So that's hypergeometric distribution. And for problem 3, the formula of E expectation of x plus y is equal to expectation of x plus expectation of y only works when x, y are independent. That is false. It works at any time because the expectation follows linear transformation or linear operation. And for problem 4, the formula EXY equals to EX times E of Y works only when X and Y are independent. That is correct. So that's when X, Y are independent. So do remember the difference of these two equations. And also another thing I want to highlight on problem 3 is that the linear operation is not just addition, it's also multiplication by a constant. So expectation of ax plus by, where a and b are constant, is equal to a times e expectation of x plus b times the expectation of y. And problem 5, the expected value of e of x of a random variable of x is always in the range of x. That is definitely wrong, because a counterexample is that, for example, the expectation of if I roll a die, a six-sided die, so that's 1, 2, 3, 4, 5, 6. That's the range of x, but the expected value is 1 plus 3 plus 4 plus 5 plus 6 over 6, which is 3.5. It is not in x. It is not in the range of x. And for problem 6, the statement expectation of x equal to 5 means that half of the time x will be greater than 5, and half of the time x will be less than 5. This is definitely wrong, because a counterexample, this is also a counterexample. A counterexample of this can be a random variable will always output 5. So if I have a six-sided die, but on each side of die there's only 5. Of course, the expected value of one row will be 5, because all the side of the die is 5. So that means probability of x greater or equal than 5 is 1, and probability of x less than or equal to 5 is also 1. So problem 6 is false.